Welcome back. So what we're gonna do is, first of all, I want to save a copy of the scene, and I'm gonna save it as dynamic collision 2. Alright, and first, we don't need a cloner, so we want to take the Voronov factor out of the cloner and put it in there, and just get rid of the cloner object. So and then everything else is fine. It's like that, yeah, okay, that's fine. We don't also need a random because we're not going to use it. Right, so basically we have these objects here. When you play, it's just one platonic object exploding in the center, which is so cool, like a fireworks or whatever. Alright, before we can even get into Espresso, you need to put down a null, and let's name this null Espresso. Just name it Espresso. Oh, Espresso with double O. It's not bad. It just doesn't do anything. Just we want to put an Espresso tag on it. This is just for us to be putting our Espresso tags on it. It doesn't do anything. So in this Espresso tag, now we begin to do something. So first thing we're gonna do is to go down to the Procedural4D, and I'm not gonna talk about all the nodes in here. I'm gonna do separate tutorials to explain what each of them does, but I'm just gonna focus mainly on achieving this effect, just to let you know the workflow. Alright, so if we go down to objects, we have a node called copy. Copy is essentially like a cloner. It just copies as its name says, so it needs to be fed with an object to copy and the number of copies you want to make, and that's it. So now what object we want to copy is the RBD. We don't want to copy only this. The reason why I put them in a null is because then we can add more objects to it, and whatever we do, we copy it. So we just want to bring this object here and expose the object port of it, and then connect it to the object of which we want to copy. And I'll show you something quick happened here. We've got a new node here called node, and the name of the node that we plugged in. That means it's being copied 5 times, but right now they're all sitting in the center of the scene, so it seems like nothing's happening, but you've actually got 5 copies of it. Let's make like 10 copies, and whenever you change the copies, you need to hit on update so that it re-updates it. So the next thing we're gonna do is to randomize the positions of our objects. So we want to go down here to effectors, and then we want to bring a random effector. And random effector really requires 2 things before it will work: the objects and the object index. And whenever you see any node that has this, it means it needs to be plugged into something before it will work. So you go to miscellaneous, and then we have execute port, just like SSI. If you're coming from the background of some image, you'll see this. So we can plug the execute port into any of it, and we get an error. Yes, because I told you there are 2 main important things that need to be fed before it will work. That's the object and the object index. So how do we then get the object index? Because if you come on the object, we've got get object index, but we go into that. For this tutorial, I'm just going to use loop. We have loop. This essentially is going to loop through all the copies here and give you a single object one at a time, or all the objects will be fed in here, and then you also get the index. So what we're going to do is to put the objects in here, and then we will want to use the multiple objects, because that's what we want to randomize. We want to do it at once, but we want to iterate on all the multiple objects in this loop, and then we also want to feed in the index to it. And now everything seems to be working. If I clear the console, there's no error, and now we can start to dial up some values in here, and look at what's happening. It keeps on whoa. Yes, because we did it in such a way that it's more like simulating, so it keeps on adding this number 95 to it, so it's up to infinity. So you just need to, if you set in a position and it's the first thing in the execute port, you want to make sure you set it to reset, so this way it's gonna make sure it doesn't add up to it. Alright, so now we can just randomly position it, dial up the z-axis a little bit, position it that way. I think it's okay like this. And now we also want to make sure that we lift all of them up, and we can do that by bringing in a plane effector. A plane effector basically is plane, so it's gonna do it, apply it to it, like, I mean, it also needs to be fed by the object and also the index. And now we don't want to set that to reset. So what you set that to reset means whatever you've done here before, you're gonna reset it. We don't want to do that. We want to add it to it. So this time we just lift it up and then maybe just bring it here a little bit, and then maybe here a little bit. Let's go into the random and just spread it a little bit more, maybe on the z-axis. All right, so just something to randomize it. Also, we need to randomize the scale. Yeah, so we get big ones and then small ones. I think we should just minimize this a little bit, just to your taste, All right, so we've got this going on. All right, good. So this is what we have here. Good. All right, so forget about the one in the middle, because that one is the original one, apart from the copies, because if we shut it down, we're not gonna see it, so it doesn't really create any problem. So what it is that we can just shut this down, because we don't need it. Shut it down just to make some space. Okay, so the next thing we're gonna do is to make sure that we detect the collision, and when we get the detection of the collision, then we can do a lot of stuff with it. So by detecting it, we've got an espresso. If you go to espresso, go to dynamics, and then go to dynamic collision. It actually takes in object A and object B. We want to be able to compare the dynamic objects, which is the Voronoi, because the dynamic tag is on it. The single objects are coming from here. So let's just see what we are getting actually from this. Let's see what name it gives us, because this object is what has been cloned and it contains children. So what this is actually putting, or this is coming out, is going to be the RBD. It's a null object, and that null object does not have any dynamic tag, so that's not what we want. So we want to be able to step down in the null object of each of them and get the Voronoi fracture from it. To be sure of what I'm saying, I can just easily go to general, put down an object nude. It doesn't do anything, but we want to get an attribute from an object, which is this object. We assign it to this as a reference, right? And we want to display the name. So we got basic and name, and if we put down a result nude and change its data type to string, we can be able to feed the name here and see what it is. So I told you. Now the name we're getting here is RBD.9, because it's from 0 to 9. So RBD, and we cannot get the dynamic collision on RBD9, but rather we want to use RBD9 and go down into RBD9 and get the Voronoi fracture. You're seeing RBD9 because it has run through 0 to 9. So wherever we do to it, it's going to start from the first one to the last one. We have an object here. If you come down here, you can get find by path. Is what find by path does is it uses characters to use like a direction to navigate in a null, where D stand for go down, N stand for next, and U stand for up, and all that. So we want to feed in this object there. That's the RBD9. And we want to go down in that object. So it's so in the path we're going to put D, which is correct. So it's going to step down in it, and now let's check what object we get from that, and that's the Voronoi fracture. So correct. So now we've been able to dive down in the hierarchy of the objects, each of them, and got in the Voronoi object. So we're good to rename this as Voronoi, so we know what it is. Voronoi. Good. We can put this aside. So now we've got an object A, so that's going to be our object A. And what's going to be our object B? Simply we drag this colliders over here and expose the object parts and feed that one as the object B, and that should do the trick. So now we are able to compare the collision of each of the object from 0 to 9, and we're able to get collision. Now let's see if we actually get collision, and this doesn't give us any boolean output that says true or false, so we need to create that true or false situation. So we can take any object here, for instance the count. We can put a result null down here to visualize what we're getting from the count, if it's actually a result node. And let's see what's coming out from the count. Basically 0 because nothing has touched. So let's just play it and see if we're getting something. So once it hits, we get some numbers popping out. It means there's a collision, because the number of the collisions that has been detected between these two is just gradually becoming 32, and it's really confusing. You don't really know what it is, which number is 32, because you have a lot of pieces going on here. Well, the issue here is we can't tell which of the pieces belongs to which instance of the copy. So what we can do to tell is that we want to check that if the count is greater than 0, then it means any of the pieces have touched, and because we are looping, it will do the same calculation on each loop and goes to the next one. So whenever any of them touches, we can tell. So what we have to do now to get that is to go to Espresso and go to logic, and we go for compare. And what compare does is simply compare two things to check equality. So we're gonna feed the count into the input 1, and then we want to compare to input 2, which is 0. So we want to change the function to not equal 0. So what we essentially saying here is that if the number of count is not equal to 0, that means it's greater than 0, then there is a collision. So this is only going to output either 0 or 1. If we put that, pipe that in the results, and let's see, if it hasn't touched the ground, it should stay 0, but if it touch, it should stay 1 instead of giving us the incremental number. So you can see that as soon as it touches, it changes to 1, and this is our boolean that can change our life. We can do a lot of things with this boolean that we've got in right now. Now what we're going to do is to use a little trick. Because we want to show the original platonic in the beginning before it touches any object, I'm going to set the visibility of the Voronoi fracture on only if it touches any object. So what we're going to do is to bring a reference of the Voronoi fracture here. This doesn't mean we are affecting this, we just need a reference. Right now we're just referencing this one here, just only one instance, but we're going to change that. So it's going to use a different object. It's going to use the objects we get from here, because we've said that we're going to use this Voronoi instead of this one here, but we needed this to get the attribute, the required attributes from it. That's it. Alright, so what we want to do is to expose the object that we want to reference. So we want to reference this Voronoi that we got here. What do we want to set on it? We want to set its basic visibility in editor, and then its visibility in render, and we want to set it on or off. So let's just put the boolean in and see what we get. So now when we put it in and play, this is what we get. We get a reversed of what we need. Upon collision, it rather goes off. So that means we need to reverse this boolean, and we can do that easily by going to Espresso and then going to boolean, and we choose not. This is gonna take whatever is true, make it false, and then we rather put that one in, and we can see that immediately we get the effect that we want. So you don't see the Voronoi fracture until it collides with something, and that's a cool effect on its own. So that means we can use the reverse boolean, which is the original boolean, to trigger the original platonic visibility on, make a copy of this platonic. So we're gonna hit on control and make another copy, but we don't want it to stay under the fracture because we don't want that one to fracture. So we want to bring it out of it, but we don't want it to be the first object in the list, because that is gonna affect our search here, because this is searching down the first one, and that shouldn't be platonic. So we need to switch and bring this up, so this becomes the second one, but not a parent of the Voronoi. So this is not going to get disintegrated. So let's just see, we've added a new object. We can't see it because we've added a new object, and we need to update our copies. So come back to the copies. There are two ways you can update: by hitting the update button, or you can just delete the node. It's going to automatically create a new one for you. It's the quickest way. So either by clicking here or deleting it will update it. Alright, so now we've gotten our new objects added to the copies. So one is staying at the same place and one is just gliding, and good. So what we want to do is to set the visibility of this platonic on, but upon collision set it off. So let's just bring it into the scene as a reference as well. We can get rid of this and also expose the object, and like we did to it, we're not really affecting this single object here, so that's why we export the object. We expose the object port and tell it which object we want to. So now we need to search. The way we search for the Voronoi, we can search for this as well. So we can make a copy of this and then name it platonic and feed the object to it, and but instead of going down, we go down and next. So D and N, that will get us, if we want to be sure, we can plug it in here to see the name, and that's platonic .1, so it's correct. So we feed it to this object. So that's the object we're gonna set attributes on now. So what attribute do you want to set? It's gonna be basic, and go to visible in editor, and then go there again, visible in render. Alright, so now we can give the original boolean to it, because this is doing the reverse. Then the original one will do what we want. So now if we start playing in the beginning, it shows, and upon collision you see it should vanish. So that's so cool. That's another effect on it on. Right, it looks good, isn't it? So we get something cool here. Good. But now the only thing that we're missing here is the dynamics on this Voronoi, because it hasn't been applied to the platonic. That's why they're staying where they are. We can say, we can just make another copy of this and put it there, update, yeah, it will work, but we've got a problem, because then the Voronoi will collide before they even get down, because it sees this as dynamic object as well, so it will collide before it even touches down. So that's not the best way. So let's see how Procedural4D can do that for us. Since we have the object here, we can now copy the dynamics on the Voronoi fracture and assign it to the platonic. How do we do that? Simple. Just go to Espresso and go to dynamics again, and then we have dynamic body state. Which dynamic body state do we want? Where do we want it? We want it from the Voronoi, so we just pipe in the Voronoi into the dynamic body state. And what we want from it, we just want, you can get a whole lot of attribute of dynamics. You can do a whole lot procedure, man. Alright, so what we want is global matrix. Yeah, some people say matrix, or whatever it is, but it's matrix. That's what I would say. Yeah, no one can tell me nothing. Alright, so we got the global matrix, and we want to assign it to the platonic's global matrix as well. So we just expose that and simply just pipe it in, and boom, it works. It doesn't work really properly. Okay, why are we having this issue? Okay, and the issue is it should work, but because we made changes, because we're copying the dynamics, we need to update our clones again. So we just delay it and then just start again. See, and you can see that it's working now. You can see that it's working now. Perfect. So this is what we wanted to achieve. It's really great. I don't think you could do this with cloner. Wherever we make any changes, it's gonna go through the same thing and then affect it. So we just update it, make like 2 copies of it, and then everything's supposed to work perfectly as it's supposed to be. So it's just tell it back to 10 copies, and let's just see what we have. Now what we have to do is to factor in the pieces of randomize the pieces of the disintegration. So what we're going to do is to go to nude Espresso, and then what we want to bring down here, if you go to logic, we have condition. So we basically have 2 inputs here. One is going to be 2 pieces and the other one is going to be 10 pieces, and we need a switcher to be able to switch between these 2 and 10, and we're going to do that by using the index of each of the copies. So if we bring this down here, we can get in this right here as the switch. That should do just fine. But one thing, I think we can get rid of this to clear our scene a little bit. We want to put that math node. We'll go to calculate, and then we get a math node, and we want to feed the index into the input 1 of the math node and change the function to modulo. And what it does is it's going to modulate it throughout the whole 10 copies, throughout the number of indices, every index. So we're going to say modulate by 2. So what it's going to do is every 2 objects, it's going to switch between the numbers 2 and 10. So if we use that as a switch, it means every 2 objects either use 2 or 10, and that is going to be fed into an attribute on this Voronoi fracture. When you go to source and you go to point generator, we want to affect this point amount. So we need to bring this object into the graph as a reference, of which we're going to change by exposing the object. And what is the object we want to set? And that object is here. We can get it from here, Voronoi fracture, but I think we if you want, we can actually get it from here because it's the same object. So we can feed it into it, and that way it's reasonable and you understand what is going on. So now we can bring our switch over to this side and then use it to switch. I think the platonic can stay here. Now our switch can now be fed into an attribute. So when we go to distribution, we're looking for point amount, and we can use that as the input. So now we're switching between 2 and 10 based on the moderation of the indices that's coming from our copy node. So let's see if we get something cool here. So some of them will break into 2 and some will break into 10, every 2 of them. And this is what Procedural4D can do. So you can go back in here and say modulate over every 3 objects, and that's gonna just do fine. Just procedural every 3 objects. So you can say okay, so we just split it 20 and 3. So let's see if we get some changes over there. Great stuff. So some divided into 3 and others divided into 20 and all that. So I mean, you can do some cool stuff with it. This is just a little that you can do. There's a lot. This is just a little. So you know what, I'm gonna be doing a lot of tutorials now to explain each of the tools and also achieve a lot of effects. And let me know, just comment down there anything that you wish you want to achieve, and ask questions and I will answer you. And my name is Eric, and if you like this video, please subscribe to FX3 so we can make more videos for you. Alright, if I get comments, then I'm gonna release this too, so you can have it and use it. So thanks for watching, wasting your time with me. Alright, see you in another tutorial. Waste your time again.